Hello, you absolute legends. This is a problem using a chemical equilibrium expression. Here we have a balanced chemical reaction with methane, chlorine gas, producing dichloromethane and hydrochloric acid. Now the reaction started, and after a period of time, the moles of methane, chlorine, and hydrochloric acid were measured. So there was 1.7 moles of methane, 3 moles of chlorine gas, and 2.5 moles of hydrochloric acid. This question is trying to get to how many moles of dichloromethane were present in the reaction at equilibrium. So let's write the equilibrium expression and fill in what we know, and we can rearrange it and solve for the moles of dichloromethane at equilibrium. So any equilibrium expression for capital K has the concentration of the products in the numerator. And because the balanced chemical reaction has 2 equivalents of HCl, we have a 2 there. We have the reactants in the denominator. And recall that those square brackets mean moles divided by liters. So we start by filling in what we know. So we were told that this all took place in a 1 liter vessel. So to get these in molarity, we can divide them by 1 mole, 1 liter. Now we're also told the K value, the equilibrium constant for this reaction at whatever temperature was ran at, equals 0.5. Now that we have the equilibrium expression written using the balanced chemical reaction, we fill in the numbers that we know and try to rearrange and solve for our question mark up here. So with the numerator, this first reactant right here, question mark moles divided by 1 liter. You can also put in X moles. Then over here for HCl, to convert this into molarity, moles divided by liters, I can do that in my head. 2.5 divided by 1 is going to be 2.5. And this 2.5 molarity is going to be squared. Down here in the denominator, the methane, the molarity is 1.7 divided by 1. That's going to be 1.7 molarity. 3.0 divided by 1 is going to be 3 molarity. And don't forget that that's squared there. So now what we have here, we try to rearrange and solve for the question mark moles of dichloromethane. I'm going to do my squares first, get rid of those. So 3 molarity squared is going to be 9. And I'm going to drop my units. I'm going to drop the capital M's because formally equilibrium constants doesn't have units at the end of the day. 2.5 squared, 6.25. 1.7, so I'm just going to not touch that for right now. 1.7 times 9 is going to be 15.3. I'm really just trying to isolate X or solve for X. I want to get rid of this denominator or get rid of this fraction here on this side. So I'm going to multiply both sides of the equation by 15.3. 7.65. So now I have 7.65 equals question mark moles of dichloromethane divided by 1 liter times 6.25. I'm going to get 6.25. Divide both sides of the equation by 6.25. So that is 1. I'm going to rewrite this without the parentheses. And I'm going to erase these units in the numerator equals moles, and these units in the denominator equal liters. And because we're talking about an equation here, these numbers have to equal each other. And because it's just, I can multiply both sides of the equation by 1. I can do that in my head. So there are 1.224 moles or if you want to round that to 1.22 or 1.2 moles, those are also great answers, of dichloromethane present in that reaction vessel at equilibrium. Now, if you want to double check your answer, a great way to double check your answer is to plug in all the molarities into the capital K expression, take everything to the square, multiply and divide, and you should get a K value that's pretty close to 0.5, what we were given in the problem. I hope this helps. Thank you.